In this video, we're going to evaluate the following mind-blowing integral that almost no one has seen before. And we're going to do it right from scratch and see a lot of beautiful math along the way. So let's dive into it. We have the integral from 0 to infinity of x to the negative log x dx. The very first step is to understand what is x to the negative log x even mean? What is it really? So let's recall that a to the b, if a and b are numbers, a to the b is going to equal to e to the b log a. That is the definition of a to the b. For example, pi to the pi is e to the pi log pi. You can't say I multiply pi with itself pi times, but in the case when b is an integer, for example, this definition matches up with the usual definition just using log laws and exponent laws, because we get e to the log of a to the b, which just gives back a to the b if we can define a to the b as usual. So with this in mind, what we can do is we can now write x to the negative log x. And this is going to be really cool. This is going to be super exciting. We're going to get e to the, so b is negative log x here. So we're going to get negative log x times a. Okay, so a in this case is times the log of a. And a in this case is x, so it's going to be times the log of x, which is going to equal to e to the negative log x squared. So that already helps us simplify what we have to integrate, because now all we have to do, and I say that because it's still a challenge though, but we are going to get integral of 0 to infinity of e to the negative log x squared dx. Okay, so that's going to be the integral we're going to have to evaluate. And this is the point where we have to be clever again. We're going to have to do a substitution to find this out. So the substitution we're going to do is we're going to put u is equal to the log of x. Okay, so that's a reasonable thing to try. Let's see what happens if we try that. So if we try u is equal to log x, and I'm going to use a red pen now. If we try u is equal to log x, then we're going to get the following. Okay, we're going to get the du is going to equal to 1 over x dx, because the derivative of log x is 1 over x. But now we want to write dx in terms of u, right? In terms of u and du. We want to now substitute everything in terms of u. But how do we write x in terms of u? Well, luckily, if u is log x, then x is going to equal to e to the u. So therefore, we're going to get x is equal to e to the u. And now we get that x du is dx, or e to the u du is dx. Okay, so we get e to the u du is equal to dx. The next question is, so I'm going to now write this as integral from something to something of e to the negative u squared times e to the u du. And what are the new limits of the integral? So effectively, as x goes from 0 to infinity, log x is going to go from log of 0 to log of infinity, which very precisely is the limit, not log of 0, but the limit as x approaches 0 from the right of log x, which is negative infinity, to the limit as x approaches infinity of log x, which is positive infinity. So now we're just going to get the integral from negative infinity to positive infinity of e to the negative u squared times e to the u du. That's the integral we're going to have to calculate. And what's going to be the trick here is that this integral here actually does not have an antiderivative that we can write down. So the only way to calculate it is going to be to use some trick to write it in a form that we can then work with. And we're going to do something here, which is we're going to now collect the exponents using basic exponent laws and write the exponent as a negative of a perfect square. Okay, that's going to be the next step, and you'll see why I'm doing this very shortly. So let's explain what that means. And this is one of the most, beautiful integrals in math. Okay, we're going to actually lead to one of the most beautiful integrals in math. Let's now work out how to simplify this integral. So we've got the integral from negative infinity to infinity of e to the negative u squared plus u du. And now what happens is we want to write out what's in the exponent as negative of a perfect square. Okay, so what's in the exponent is going to equal to, so I'm going to put this here on this side of the board. I'm just going to write this in the middle. So we know that negative of u squared plus u is going to equal to the negative of u squared minus u. And we want to write this u squared minus u as a perfect square. Okay, so how do we do that? So we complete the square basically. I'm just going to refresh that briefly. We want to add something to u, let's say some constant c, so that u plus c squared has the same u coefficient as u squared minus u. So here we're going to get u squared plus 2 times c times u plus c squared. So what c should we choose so that the u coefficient here matches up with negative 1, which is the u coefficient in what we want to complete as and to make a square. So we want to choose c is equal to negative half, and then we get 2c is negative 1. And if c is negative half, then u plus c squared, or in other words u negative half squared, is just going to equal to u squared minus u plus half squared by the binomial theorem. And then to get the u squared minus u we want, we have to subtract 1/4. Okay, so therefore it means that u minus half squared minus 1/4 is going to equal to u squared minus u. And that's now going to lead us to our next step, and we're going to see this integral is going to have pi and e in the answer, which is really amazing. So we're going to get integral from negative infinity to infinity of e to the negative of this thing, okay, because negative of u squared minus u is going to be negative of this perfect square minus 1/4. So it's going to be e to the negative of u minus half squared, and then it's going to be minus 1/4, okay, du. That's going to be the integral. So we're going to get there, and now what we can do is we can take out the e to the 1/4, okay, because negative of negative 1/4 is positive 1/4. So now we just get out the e to the 1/4 comes out front. It's a constant, integral negative infinity to infinity of e to the negative u minus half squared du. So that's what we're going to get. And now that we've got this far, okay, the u minus half squared, we're now going to do a simple substitution. We're going to set t is equal to u minus half. Okay, so if t is equal to u minus half, the limits negative infinity to infinity don't change with this transformation. You're just translating the number line by half to the left, and also dt is just going to equal to du. So nothing's really going to happen in some sense. It's just going to become integral e to the 1/4 times integral negative infinity to infinity of e to the minus t squared times dt, and that's going to be the answer. But this is not a very nice answer. I mean, we haven't evaluated the integral of negative t squared dt. That's what I'm going to do in the next video, okay? So it's going to pop up on the screen. It's one of the most fundamental integrals in calculus. Very famous integral is called the Gaussian integral, okay? So it's a super famous integral, and in the video I explain why that integral is actually equal to the square root of pi, okay? That integral there is equal to the square root of pi, and once you've seen that video, you get that our answer, integral x to the negative log x dx from 0 to infinity, is actually going to equal to the 4th root of e times the square root of pi, which is also going to be, another way of saying it is, it's the 4th root of e times pi squared. Pretty miraculous. It has both e and pi in it. So check out the video. It's going to pop up on the screen here. It's going to explain why this integral negative infinity to infinity of e to the negative t squared is a square root of pi. It's a very clever trick. Check it out, and I'm going to see you there. Wish you all the best, and I'll see you in the next video.